Okay, this is 4.9, calculating the area of composite shapes. We need to know what the word composite means. It just means different figures, different shapes that are put together, okay? For example, having a square sitting on connected to a triangle, or having a semicircle connected to a square. Okay, it's putting different shapes together. Okay, irregular type shapes. So let's try these. Let's look at this figure to the right. Is the area of this shape more or less than 48 square feet? Well, we know that the area of a rectangle, if I was to connect this whole top together right here, that would form a rectangle. We know that area of that rectangle is length times width. 4 times 12 is 48, but you can see we've got a little bit of a cutout in there, okay? And that cutout is going to make it less than 48 square feet, because if I didn't have the cutout, it would be 4 times 12 is 48 square feet, but because I have the cutout in there, it's going to be less. Okay, so I'll write the word less because of the cutout at the top. Okay? So over here on the right, we have what we call a composite shape. It's different shapes put together. The question is, how do we calculate the area of this? Well, we have to have a little bit of information. We need to know the lengths of certain sides to be able to calculate it. So what is the question asking us here? It says Danielle wants to use paving stones to pave a regular loading area outside her store's entrance. Paving stones are about $8.50 per square foot. How much should she expect to pay? Well, the first thing we need to do, like we did before when we're calculating the area of regular polygons, or irregular polygons, we divided that shape into triangles. Well, if we can do that, great, but sometimes it's even easier. We can just divide it into shapes that are pretty easy to calculate. So how can you divide the shape on the left here into areas that you can calculate? Well, if I was to draw a dotted line across here and another dotted line across here, you can see that I've divided that object into 3 easy shapes. We'll call that area A, we'll call this area B, we'll call this area C. You can see that area A and area C are identical, okay? You'll also know that the reason I know they're identical is because this line here is equivalent to that line there, that length there. This length is equivalent to this length, which is equivalent to that length, which is equivalent to that length. So if this is 2 feet, that means that this must also be 2 feet, and this must be 2 feet, and this must be 2 feet. Okay, and if that's 4 feet at the top here, that means that this down here must also be 4 feet. Okay, so what is the area of each part? Well, area A, we know it's just a simple rectangle. It's just 4 times 2, okay, which is equal to 8. Area B, well, we know that if this is 4 feet from here to here, and this is 2 feet from here to here, okay, then we just take 4, subtract 2, and we get 2, so that area is just 4 feet, or this is 2 feet across here, and if this is 2 feet here, and this is 2 feet down here, and this is 12 feet all the way on this side, if I take 12, subtract 2, and subtract another 2, I end up with 8 feet inside here. So the area of area B is just 8 feet times 2 feet, which is equal to 16 feet. And then area C is the same as area A. It's just 4 times 2, which is equal to 8 square feet. So what is the total area of the loading area? Well, it's just 8 plus 16 plus 8, which is equal to 32 square feet. So what is the cost for paving stones? Well, it says it's $8.50 per square foot, and I have 32 square feet. So it's just 32 square feet times $8.50 per square foot, which is equal to, let's take our calculator, and I get 32 times $8.50 per square foot is $272. So it's going to cost her $272 in paving stones. Okay? Example 1. This is a good example of a composite shape. We have a square bottom part of a window attached to a semicircle or a hemisphere at the top, and we want to calculate the area because this will give us the area of glass that's in there. So Liam is a window installer, a Norman window. That's what this kind of a window is called. It's called a Norman window. It has this shape. What is the area of the window? Well, the solution is the total area is just the area of the square. That's on the bottom because it's 3 foot by 3 foot, plus the area of the semicircle. So we need to know a couple of formulas. We need to know the formula for the area of a square. Well, the area of a square is just one dimension squared, so it's 3 meters squared, okay, which is 3 times 3 is 9 square meters. The area of a semicircle, okay, that's just equal to, well, the area of an entire circle, okay, because this is a semicircle, means it's half a circle. So if I find the area of an entire circle, I divide it by 2, I've got the area of a semicircle. The area of a circle is pi times r squared, or pi r squared divided by 2. Okay, so it's just pi times, now we need the radius. Now the radius, we know, is from the center to the outside edge, to here. Now if that whole distance is 3, that means that the radius, that's the diameter of that circle, is 3. The radius must be 1.5, not 3. So it's pi times 1.5 squared divided by 2. So let's take our calculator. So I take second function, pi, multiply that by 1.5 squared, and I get an answer of 7.068. Let's round it to the nearest 100, so 7.07. 7.07 meters squared. So the area of the window is just 9 for the square at the bottom, plus 7.07 meters squared, and I end up with an answer of 16.07 squared. Okay, didn't ask us to round it to, so I'll leave it at 16.07. Okay, so you can go ahead and do example number 2. It's just finding the area of different shapes and adding or subtracting them together. Okay, and you should have no problem doing it. Okay, go ahead and do the practice.